Evet.
Hello,
Abi.
Yunus, how are you?
Gel abi siz iyisiniz.
İyiyim ya, sen nasılsın?
Kötü değil.
Çok kötüyüm.
Ay kötü değil kötü değil.
Ha. Okula gittin mi bugün?
Evet abi.
Hangi konu işliyorsunuz okulda?
We're doing like a recap on log and then we're gonna start trig I think.
Hmm, tamam. Seninle neredeyse bitirdik yani. Bir de ve tekrar işlersin. Ya, tekrar öğreteceğim de böyle in depth ama biraz revision yapalım.
Hı hı.
Şimdi bazen unuttum deyince aklına biraz artık şey
Abi
geliyor.
zaten math yani benim okuldaki yani en least worry'im yani.
Nasıl?
Yani it's the least of my worries yani.
Ha.
Öbür sınıflar biraz zor. Onları daha çok
Ama
kapalı.
Yunus, okul tamam da ama sen kendini üniversitede işte üniversite hazırlıyorum gibi öyle bak yani.
Hı
Ve sen sadece okul için değil de yani çünkü şu an biraz daha ileri gidersek artık üniversite gittiğin zaman yani mesela bilmiyorum ne okuyacaksın da yani mühendislik if you just go to engineering field or computer science or that requires math, you know, this foundation is going to help you a lot. But actually, you know, işte artık basit sorular çözebiliyorsun ya. Artık biraz üst seviye çıkmak lazım yani. Yani neden
hı.
bu oluyor? Neden bu formülü kullanıyoruz? Bu formül nereden gelmiş? İşte IBL learning diyoruz ya. Inclusive based learning yani. Every time you're asking yourself, questioning yourself. When you actually question yourself, you're going to learn a lot. You don't forget easily. Hani geçen sordum ya işte science form hatırlıyor musun? Unuttum dedin ya. İşte bu yani deep learning değil yani bu. Çabuk unutuyorsan demek ki sadece calculation yapıyorsun yani. Ama unutsan bile hemen sen
Hı
elde
hı.
edebiliyorsan if you can reconstruct what we have learned before or if you can derive the equation based on the definition, that is deep learning. Çünkü
Hı
artık
hı.
sen temel şeyleri biliyorsun. Artık deep learning'e geçmek lazım. Artık formülleri ispat etmen lazım. Yani mesela quadratic equation neden? Exponential properties neden çalışıyor? Sine rule, why it works? Cosine rule, why it works? Pythagorean theorem, why? For example, okay?
Hı hı.
Başlayalım Yunus. Şimdi yavaş yavaş sadece bilmek yeterli değil. Our purpose is also to increase our speed. Can you understand or comprehend the question fast and define your variable fast and set up your equation and also solve the equation fast but correctly without making mistakes. Tamam, başladık o zaman. Biraz şey yapalım. Belki vaktimiz varsa e, biraz logaritma üzerinde çalışırız. Tamam. Şimdi birkaç tane soru kalmıştı. Bunu bitirelim bu şeyi. Şurada kalmışız. Şu soruyu 3 dakika çözebilirsen artık derim hemen geçelim başka şeye. Soruyu okum.
Alright, a tank can be filled by two pipes in 1 hour and 20 minutes. If the two pipes are to fill the tank individually, the smaller pipe will take 2 hours more than the bigger pipe to do so. Find the time each pipe will take to fill the tank separately.
Anladın mı? İki tane hortum var. We have two pipes. One is big, one is small. Since they have one is big, small, they have different rates, right? So every minute, different amounts of water is poured into the tank from these pipes or hoses, whatever you call this. Okay.
Sure.
But if you open them together, two taps, let's say, open together at the same time, they can fill the tank in 1 hour and 20 minutes.
Yeah.
But if only one pipe opens by either small or big one, it says that if the two pipes are to fill the tank individually, the smaller pipe will take 2 hours more than bigger pipe to do so.
Hmm.
Find the time each pipe will take to fill the tank separately.
Hmm.
Yunus sana 3 dakika bu warm'a başlangıç bakalım. Hiç çözmeye çalış. Ondan sonra beraber bakarız, tamam mı? Sen bir düşün yani biraz e, critical thinking.
I have a question.
Yes.
How should I represent the hour and 20 minutes? Like a decimal or a fraction or
First unit, did you actually suppose this is our container, rectangle container, or
yeah,
whatever it is? Okay.
yeah.
And suppose this volume, whatever it is, let's make actual volume. Let's say this 1 unit. Okay, maybe 1 ton or 100 milliliters, whatever it is.
Mm-hmm.
Now we have two pipes, right? The small one and big one.
Hmm.
Each pipe has different rates, right?
Hmm.
So the smaller one, let's say this R liters, whatever it is per minute or per hour.
Hmm.
So this one is capital R liters per hour or tons, whatever unit is here.
Hmm.
Okay. So another first one is saying that a tank can be filled by two pipes in 1 hour and 20 minutes. So first, let me just convert it into hour. 1 hour and 20 minutes is equal to how many hours?
Like as a fraction?
4 over 3, right?
Yeah,
4 over 3. So if you open them together, the rate will be R plus R, right? Capital R.
yeah.
So the time is 4 over 3, right? After this many hours, it will be full, 1 unit, right?
Mm, okay.
But if the two pipes are to fill the tank individually means that if you just open the small one, right?
Hmm.
It takes, let's say, it is T plus 2, and it can make it full. But how about the big one? It's only in T hours it can make the container full, right?
Hmm.
Now, from this equation, I can write the first equation is lowercase r and capital R is equal to 3/4. And how about from here? You see, from this equation, T plus 2 is equal to 1 over R, right? And the second one, T is equal to 1 over capital R, right?
Yeah.
And we're just talking about this. Now, as you see, the differences too. So now, can I write here 1 over R minus 1 over capital R is equal to 2?
Wait, how?
Because from this equation, if
T
you
plus
move this
2
2
equals.
t to the right hand side, right? What is t? Actually, because the difference in the 1 over r is time, right? Taking for
Oh,
small.
yeah, yeah. If you subtract them, it's just 2. Because
Actually,
they,
this one's
yeah,
time, and
yeah,
time, the difference is 2 hours.
yeah.
Because smaller one takes longer time, bigger one takes shorter time, right?
Hmm. Yeah.
Now, system of equations. How do you solve this, Yunus? Substitution, right?
Yeah.
Okay, now if you just
I
change
guess
the second one,
do one
cross
of the R's.
multiply, can I write here capital R minus lowercase r is equal to 2 times R times capital R.
How would that work?
I just multiply each side by capital R and R.
Okay. Oh,
I
okay,
multiplied
okay.
each side by R, capital
Wait,
R,
wouldn't that
R
make it
times
like
capital R.
smaller R minus bigger R?
Yeah, two rates.
Like
Because
for
I
the
don't want to deal with
equation.
fractions.
No, no, for the equation, wouldn't it be the smaller R minus the bigger R?
Hmm?
1 over smaller R minus 1 over the bigger R.
Yes.
Wouldn't that, like, once you multiply the bottoms, wouldn't that be smaller R minus the bigger R?
Yeah, the first one, if you multiply each side by R times capital R, this R cancels each other. We have capital R left, right? And the second one, capital R's cancel each other. We have only small r left, right?
Wait,
I'm
what?
doing like this. 1 over R, right?
Mm-hmm.
Multiplied by R, capital R, minus 1 over capital R, multiplied by R, capital R. On the right hand side, 2 times R,
Oh,
capital R, right?
so they cancel. Okay, that's why it's big R minus R. Okay,
I just multiply each side by the least common multiple.
okay.
Okay, now we have two equations, Yunus. That's right, because you know how to solve quadratic equation. I have this equation. If you only can change this into hours, Okay. If you want to do it with hours better, we can change it into hours. It doesn't matter. We can find this in because it says that find the time each pipe will take to fill the tank separately, right? So 1 hour and 80 minutes is equal to 80 minutes, right?
Hmm.
At that time, this two will be, the big number. That's why I keep this in hour. So then 2 hours will be 80. Okay. That's why let's just keep it as in hour. 4/3 hours. Now we have two equations, Yunus. R plus capital R equals 3 over R. And here we have capital R minus R equals 2 times R capital R. Reduce or eliminate one of the variables and solve it.
Hmm.
Okay, 2 more minutes. Give it a try.
Uh, am I supposed to get a quadratic function?
Hmm?
A quadratic function?
Okay. Yunus, let me show you another. Because you can eliminate from the first equation capital R or lowercase r. Can I express in terms of capital R and just substitute? That's it. It may be a bit weird, but it's fine. We know how to say any kind of equation, right? Look, from the first equation, let's say we solve it for capital R, okay? From
Oh,
this
I did
equation,
that. I
huh?
did that from the bottom one. Like I did capital R equals, and I moved the negative R to the other side. But now that I look at it, I think the top would have been a lot
No, we
easier
have
if
to
I
use a
just,
linear equation, right? The first one's
yeah,
linear,
okay,
right?
yeah.
So like, for example, let's say
Let's see
lowercase
what this
r
is.
is equal to 3 over 4 minus capital R. Can we do like this? And
Hmm.
plug it into this equation. Here we have capital R minus lowercase r. So that is 3/4 minus capital R equals 2 times capital R with lowercase r. It is 3 over 4 minus r. And now if you simplify this, minus minus plus, I have here 2r minus 3 over 4. On the right hand side, here we have 2 and 4 cancel each other. 3 over 2 capital R minus 2r squared, right? I just distribute this.
Oh,
If you want to do
okay.
it yourself, just substitute this one, right? Substitute into the equation
Uh-huh.
and distribute.
Wait. How did you get 3/2? Is it,
Here we
yeah.
have 2 times 3 over 4, right? Is it equal to 3
Yeah.
over 2?
Ah, okay.
I'm multiplying 2 by 3 over 4, right?
And then minus 2R. Wait, so you do
Yes.
2 times 3/4 and then 2 times negative R?
Here we have 2r. If you multiply 2r by 3 over 4, it is 3 over 2r, right?
Oh, I see, I see. Okay, okay, I see.
And 2r times r, 2r squared.
Hmm.
And let me multiply each side by 4 because still I have fraction. Multiply by 4. Here we have 8r. By 4, it is 3. By 4, 6r. By 4, 8r squared. Move everything to the left-hand side. We have 8r squared plus 2r minus 3 is equal to 0.
Mm-hmm.
Simple. Just we know the complicated part is it's not you
Yeah.
cannot get this solution in 1 or 2 steps.
Yeah.
And do you think we can factor this? We can solve it by factoring. Try. If it doesn't work, we can use the formula.
Okay, I'll show you.
I think we can, right? Because 24, 6 and 4, right?
Hmm?
Because using AC methods, if you multiply 3 by 8,
Uh,
we get r squared plus 2r minus 24, right? So now from here, r plus 6 and r minus 4 is equal to 0. And we divide each number by 8, divide by 8. And do this. Okay, and this is 4r, 4 capital
4x.
R plus
4x
3,
plus 3, 2x minus 1.
2r minus 1, right?
Oh, yeah, I did it with x, but yeah.
But the first one is negative, so we can just ignore it. Because we're
Yeah.
talking about rate, it must be positive, right? So this r
Yeah.
is equal to 1 over 2.
Hmm.
Now, if r is equal to 1 over 2, you see this equation? We need to find t, right? Because the question is asking
Yeah, because
find
this
the
has for
time
the
each part
individual
takes.
time.
So I
Yeah.
just need the time. So if t is equal to 1 over r, now we can find the t. Now what is t? T is equal to 1 over capital R. That's equal to 2 hours
Yeah.
for small one. For big one, it is t plus 2 hours more. That is 4 hours.
Yeah.
So the
Right.
small one alone, it takes 2 hours. The big one alone takes 4 hours.
So 1, 2. Yeah, okay, I see. I see.
The challenging part is in a rate problem, and we cannot solve it just in a couple of steps. You have to use some different skills. That's the challenging part. Okay, Yunus, you have to, next time I'll ask, I'm just expecting, I ask a few times. If you can solve such question, maybe 4 or 5 minutes, just step by step, the first step, second step. If you can solve completely, it gives you a lot of self-confidence. Otherwise, every time, you say that, oh, maybe I can make a mistake, you have a fear. Anyway, let's continue, Yunus. Simplify the following algebraic fractions. And then you have to bring a common denominator and simplify.
Okay.
Can I do this in 2 minutes, Yunus?
Let me look at the question first. Simplify the problem. Oh, gosh. I don't know.
What is the common denominator?
Okay. Um, assuming I see x minus y twice.
Yeah, if you remember, x squared minus y squared is equal to x minus
Yeah.
y and x plus y,
Plus,
right?
yeah, yeah,
So now the first one is x squared minus y squared. The second one is x plus y. The third one is x minus y. So now if the common denominator is, let me write here, if the common denominator is x squared minus y squared, for the first one, we don't need anything, right? The second fraction, we should multiply top and bottom by x minus y, right? And the third one, we should multiply top and bottom by x plus y. It's rational functions. And now let's simplify.
Uh,
Can you expand x minus y squared?
X squared minus 2xy plus y squared.
Okay. Plus and distribute.
Distribute like
The
what?
second one, 3 times x minus y.
Oh, 3x
Welcome.
minus 3y.
3x minus 3y.
Yeah.
And the last one?
And then negative 2x minus 2x minus 2y.
Okay. Can you simplify the top?
Okay.
We have x squared. We don't have any x
Yeah, x
squared.
squared. And then there's no y squared plus y squared.
Also, let me write xy first.
Oh, that's after it? Oh, okay. And then plus y squared, I'm assuming.
Yeah, plus x minus
Wait,
5y,
what?
right? Plus y squared.
Wait,
So
what?
that's equal to x squared minus y
X
squared.
minus wait,
So we can
where's the x
simplify this.
where's the x minus 5y?
Hmm?
Where's the x minus 5y?
So here we have 3x minus x is equal to x.
Oh, and then the negative 3y and the negative okay, okay.
Yeah, negative 3y, negative 2y,
Okay,
negative
okay.
5y. And we have 2xy.
Yeah. Yeah, okay.
It says uh, simplify as a single fraction. We have nothing to do here.
Yeah.
Okay. And now do the next one, Yunus. Just give a try. You see the first one, B, right? Question B. The first fraction, denominator is x times x minus 5,
Alright.
right?
I have a question.
Yes.
What was the common denominator we used for A?
X squared minus y squared. X minus y, x plus y, right?
X minus y.
Because the first one, it is x squared minus y squared, right?
Yeah.
Actually, that thing is equal to, right here. So that is equal to x minus y and x plus y, right?
Yeah.
So the second fraction, if I multiply top and bottom by x minus y, they have the same denominator. And the last fraction, if I multiply top and bottom by x plus y, they have the same. They will have the same denominator, right?
Wait, so I have to like wait, so I use this like the fraction that's like the denominator of the first fraction is my common like denominator. Because like x squared minus y squared, that's just x plus y, x minus y. So if I just make the common denominator x squared minus y squared, they all go away,
Mm-hmm.
right? Is it like that?
What? I don't understand. Say again.
Wait, what was the common denominator again? Could you like
The
write it?
common denominator
Sorry.
of these fractions, the first one is x squared minus y squared, and the second fraction denominator is x plus y, and the third one is x minus y, right?
Mm-hmm.
But if I multiply the second fraction, I just do it like this, equals, let me use a different one.
Mm-hmm.
Okay, with the first one, we have no problem. X minus y squared, and its denominator is x squared minus y squared, right?
Yeah.
But the second one, I multiply top and bottom by x minus y. If I multiply top and bottom by x minus y, I know that x plus y times x minus y is equal to x squared minus y squared, right? Right?
Yeah, I'm saying like you just multiply it by the opposite.
Yes.
So then x minus y would be multiplied by x plus y.
Yes. Because x minus y, x plus y equals x squared minus y squared. And x squared minus y squared is a common factor, a common
Oh,
denominator,
you
right?
multiply the top. Oh, and then the bottom just all cancels out into one. Into one x squared minus y squared.
Yeah, common denominator.
Mm, okay, okay. So then we could put all those under one x squared minus y squared?
Yeah.
Oh, okay, okay. So,
Yeah, that's
all
the
right.
idea of combining a fraction, right? Simplifying. Simplify means that it should be a single fraction. And numerator and denominator must be the simplest form. Simplest form means that no parentheses, no like terms, right? If you look at the top, we don't have any like terms. Can I simplify? No. We don't have any like terms. We have nothing to do. Can I factor? No. Okay.
Okay, okay, okay.
And how about in question B? You see, in question B, the common denominator is, you see this x squared minus 5x. I can write here x squared minus 5x. We
Ah,
can
okay,
write
okay, I
this
see, I see, I
x
see.
times x minus 5, right?
Okay, okay, I see, I see. I got x squared. What is that? 5, 6 minus x. Yeah, x squared minus x over x squared minus 5x.
Okay. Just a second. This is two. Number one.
Okay, let me see if I did that right. Oh wait, hold on. Wait, no, no, no, no. 1 sec. I did that wrong. It should be x squared. Wait, that becomes -2 minus 9x plus 20.
So if I draw the fraction line, the common denominator is x times x minus 5, right?
Yeah,
The
yeah,
first one is already, it has this denominator. But the second one, did you multiply by x?
yeah, yeah,
So we have minus 4x, right?
yeah,
And the last one multiplied by 2 times x minus 5, right?
yeah, yeah,
So it's
yep.
2x
2x
minus
minus
10.
10. Yeah,
Okay, so here we have x times x minus 5 and x squared, negative
that's a
7x,
negative.
negative 4, negative 11, plus 2, negative 9x, right?
It's 9. Yeah,
And plus 10 minus is gone.
yeah,
So again, if you just factor the top and bottom, we have x times x minus 9 over x times x minus 5, right? This x is
yeah.
gone. At the top, we have x minus 9. At the bottom, x minus 5.
Wait,
Also,
hold on.
x are common factors, right?
Oh, okay, I got to x time x parentheses x minus 9, and the bottom is x minus 5. So the x's cancel out.
Mm-hmm.
Right.
So x minus 9 over x minus 5.
Yeah. Can we solve that? Or like, is that it?
Yeah, that's it. We have simplified,
Oh,
right?
okay,
Can I
okay.
simplify anymore? No. Simplifying the fraction means that you have to factor the top and bottom completely and cancel the
Hmm.
common factors. That's the meaning of simplifying fractions.
Hmm.
It's like, okay, now you just try
Hmm.
yourself. I'll give it 2 minutes. Question C.
Okay.
Can you simplify?
Okay. Just to confirm, x minus 5 times x plus 2 equals that, right?
Yeah.
Like x squared minus 3x minus something. I don't know. Do I have to factor the bottom too?
If you don't factor, you cannot,
Solve it.
I mean, because first, if you don't factor, you cannot see the common denominator. But if you factor this x squared minus 3x minus 10, it is just x minus 5 times x minus plus 2, right?
Oh yeah, yeah. So I'm assuming the top is gonna cancel those out. Wait, hold on. Let me check.
Oh, can we cancel this?
Wait, wait. I don't know. Let me check. Wait.
No, we cannot cancel, even though if we cancel, but we
Uh,
have to bring the common denominator. The common denominator
mhm.
is x minus 5 and x plus 2, right?
Yeah, yeah. So, yeah, I have my equation at the top. 2x squared plus 13x plus 7.
Plus 13 or 17x?
I got 13. Because negative 15. And then you have negative 2x and 4x is not 13.
13, right? Or
Yeah,
17?
13. I got 13.
It should be 17.
Wait, what?
Because the top, Yunus, here we have x squared and minus 2x minus 15, right? Okay.
Yeah,
But this 4, you multiply by x plus 2, right?
yeah,
You do have 4x plus 12, 8.
yeah.
And this negative 3x here multiply by x minus 5, right? Negative 3x times x, 3x squared. Negative
Okay.
3x times negative 5 is positive 15x, right?
Yeah. Wait.
Okay. And now if you simplify, at the bottom we have x minus 5. You better keep this in factored form.
Wait, I have a question.
Yes.
How would that be positive 15x?
Because here, if you look at the last fraction, what is it? It is something like this, right? Negative 3x divided by x plus 2, right? And you are multiplying top and bottom by x minus 5, right?
Oh, I assume it's a negative 3x.
Because this actually, when we just write fraction negative a over b, we mean negative a over b, right?
So I'm assuming the 3x is negative?
Yeah, because this minus, it goes to the top, right? You're combining. If I write like this, Eunice, a over b minus c over b is equal to what? Is it equal to a minus c over b?
Mm-hmm.
Yeah, this minus goes to the top, right?
Okay, wait. Then it should be
Then minus 2x squared,
18, 18, 17. Yeah,
yeah,
17.
plus 17x
Plus 7.
minus 7.
Wait, what?
Negative 15 plus 8,
Oh,
right?
and 8. Yeah, yeah, yeah, yeah.
And now if you look at the top, negative 2 and 7, their combination, it doesn't give us 17. That's why we cannot simple factor this.
Mm-hmm. We just leave it like that?
What is it?
We just leave it like that?
Yeah.
Okay.
And we call this, in math, every operation has its inverse operation, right? If it doesn't have
Mm-hmm.
inverse operation, it's a problematic, it's a problem.
Mm-hmm.
And that's why addition, by subtracting, you can remove it. Subtraction, addition, multiplication, division, division, multiplication. The power, right? Exponent and root, right? Square root or end root. And also fraction, decomposition, assembling. Sometimes if you're integrating, you have to decompose this. That means that I need to express this fraction in this form. And sometimes this fraction in this form, depending on the situation. So we call this decomposition and assembling. Assembling means a combining, or right, or expressed as a single fraction.
Yeah, I have a question.
Yes.
If it was like, let's say the plus 4 over x minus 5 and the minus 3x over x plus 2. Let's say the negative, like the minus came first. Like it was minus 4 over x minus 5 plus 3x over x plus 2. Do I still assume it's a negative 4?
Yeah, of course. Because when you're writing
Okay, okay,
this, you
okay.
see, if you're writing this minus, it goes to the top, right? It will be a minus c. If we have something like this, for example, a over b minus x over y over b, for example. How do you write
Mhm,
this? If you're combining this, b is a common denominator. Here we have a minus this thing's expression. We have to write in parentheses because this minus belongs to each of them.
mhm.
Okay?
Okay, okay, that makes sense.
All right. Okay. Yunus, can you simplify this in 45 seconds? If you look at this, do you recognize it? What comes to your mind first if you look at this?
Distribution?
No. A minus B, A plus B. Do you remember we have just used that formula?
Oh, it's the same thing.
Right? The same thing. The sum of two things, the difference
Yeah.
of two things. And they're asking
X.
again and again if you notice this because that formula, this A plus B squared, A minus B squared, A squared minus B squared, you are going to use them a lot in math, very frequently used formula. That's why in every algebra book, open this algebra, the first page, they give actually those formula because they are used very frequently. So if you factor this, what is the square root of the first one?
Like 1 over 2 squared? 1
Just
over
x,
4?
right?
Wait, what?
And what is x to the power 1 over 2 squared? It's just x, right?
Oh, wait. We multiply it, right?
Yeah.
Yeah,
A to the
okay,
power
yeah.
of m to the
Yeah, just
power of
X.
n. Anything.
Yeah,
We just multiply these two exponents.
yeah.
And how about 2 times y to the power of 1 over 2 squared equals what?
2y? Oh,
4y.
wait. Oh,
Yeah.
because we need to do that too. Okay,
Each,
yeah.
right? So that
Yeah.
is x minus 4y.
Mm-hmm. Mm.
That's it. Because why we are doing this again, when you can see that, it shows you have knowledge and experience or not. You may have knowledge, but if you don't have experience, you cannot see this. You can distribute, but it's a long way.
Mm-hmm.
We are practicing short way. How can I do this
Mm-hmm.
fast? And all right, that's the one question about the pattern, number pattern. Read the question.
Okay. Study carefully the pattern showing below the number of beads in each figure. Draw the next two figures and label them as Fig 5 and Fig 6.
So in figure 5, how many dots will be? There will be.
Okay, so that's 1. If that's 3, and that's 6. Oh, what?
So this
Hold on.
1
Yeah.
and 3
And
and 6, next
that's, is that 11?
10.
1, 2. Oh, 10.
We
Okay.
just added 4, right?
Yeah.
So next one will be how many?
Wait, hold on. Wait. 1 you added 2, then you added 3, then you added 4, then it's 15, then it's 21.
Yeah. If you add
Okay.
this, next one will be like this, right? 1, 2, 3, 4, and next one will be 5, right?
Yeah.
And how about the next one? 1, 2, 3, 4, 5, 6, right?
Mm-hmm.
Actually, in math, these are special numbers. They're called triangular numbers because every time uh, you can build a triangle using these dots. All right. Now, next question. Okay.
Mm-hmm.
Read the next question.
How many beads do you need for the seventh figure? Okay. One, two, three, four, five, six. So how many figures would like wait, is it saying how many you would add?
Yes. Now, how
You
many
had
bees do you need for the seventh figure? To make the seventh figure, how many?
oh
Uh,
wait, you had five there, you had six there. 28?
28. Okay.
Yeah.
So we need 28. Now, next question.
Which figure will use up 210 beads? Oh, okay. There's got to be a faster way.
Yeah. You see, if you look at the numbers, Yunus, the first one is, let me just write figure one, right? What is figure one? It is just one, right?
Yeah.
And figure two, one plus two, right?
Yeah.
And figure three, it is one plus two plus three, right?
hmm
And how about figure four?
One plus two plus three plus four.
Now, let's answer the question mathematically. High school student is saying
Uh-huh.
that which figure will use up 210 beats? Suppose the figure
Uh-huh.
n. Can you tell me how many dots will be in figure n? One plus two plus three plus dot dot dot plus n, right?
Yeah.
Because when it is two, the last number is two. Three, the last number is three. Four, the last number is four. So this will be equal to 210. Can you solve this equation for n? What is n?
Yeah, what?
Have you ever seen the sum of the first n natural numbers? This sum is equal to what?
I, I have no clue.
It
I
is n.
remember a question like this in like middle school, but like
Yeah,
in
middle school, but the problem is high school
math
math
club.
because it's involving the difference of two squares. You studied in algebra one, you remember? If you are given a sequence, right? If the first
Uh-huh.
difference are the same, it's a linear function. The second difference are the same, it's quadratic function. The
Uh-huh.
third difference are the same, it's a cubic function.
hmm
It's a
N
algebra
times
2
n
topic on
plus
this one.
one.
Anyway, the sum of the first n natural numbers, if you don't know, now you know that. It's n times
Uh-huh.
n plus 1 over 2. You know why?
Why?
Very simple logic. See, if we are adding five numbers, 1 and 2 and 3 and 4 and 5, right? Have you ever heard this name, Gauss? No? Okay, Yunus. Let me just write, okay, who is
Sounds like
Gauss?
a chemistry person.
No, he is a mathematician, one of the great mathematicians.
Mm. Yeah, I remember seeing a question like this in math club because they did like more advanced stuff and like, but I was
Can you
in like
just,
seventh grade, so I didn't
yeah, can you
understand it.
read this little bit, Yunus?
Okay.
Just two, three paragraphs about this Gauss. Because every time you're solving system of linear equations, right? Actually, this guy suggested first how to solve using elimination methods. Read it.
In my head or in my out loud?
Yeah, read it fast. Yeah, I want to listen. Yeah, read it.
Okay. Carl Friedrich Gauss was born on April 30, 1777 in Brunswick, Germany to a poor family. From an early age, he displayed extraordinary mathematical talents, performing complex calculations in his head and astonishing his teachers with his abilities. By age 7, he was already recognized as a prodigy, and at 14, he independently discovered a method to construct a 17-sided polygon using only a ruler and a compass, a breakthrough in geometry that had not been achieved in over 2,000 years. Gauss made foundational contributions across numerous fields of mathematics, including number theory, algebra, analysis, geometry, statistics, and probability. His seminal work, Disquisitiones Arithmeticae, led the groundwork for modern number theory. He also proved the fundamental theorem of algebra, introduced the concept of Gaussian curvature, and developed the arithmetic geometric mean. In number theory, he formulated the law of quadratic reciprocity and contributed to the theory of quadratic forms.
Okay.
So he did like
Now you have
all
some
the
information. Huh?
high school topics. So he did like all the high school topics like geometry, algebra.
Yeah, this
Gain
elimination
everything.
method system of linear equation, you will see when you go to college, you see his name more often.
Mhm.
I mean, this story is really popular about this guy. He was like 5 or 6 years old. And his teacher asked him, "Can you go to the whiteboard?" I mean, she was tired. She's a lady actually. And she was teaching
Mhm.
maybe first or second grade students, okay? And she just wants
Mhm.
to have some rest and tell the students, everybody calculate this. What is the sum of the first 20 numbers? 3 and 4 dot dot and 19 and 20. And this Gauss, he just actually raised his hand. He just calculated in like 3, 4 seconds. And the teacher was surprised. How
Mhm.
did you solve this? Okay. And he explained, if I just write this number in reverse order, the sum does not change, right? And he wrote like this, 20 and 19 and 18 dot dot. And here we have 2 plus 1. Now, if you add each number, each sum is equal to what? 21, right? Right? What is 20
Mhm.
plus 1? 21. 2 plus 19, 21. 3 plus 18, 21. 19 plus 2, 21, 21, right? But how many pairs do we have here?
Mhm.
20 pairs, right? So I have here 20, 21,
Mhm.
right? And if I just divide this by 2, it will be equal to 210. Did you get it?
Mhm.
He calculated at the age of 6 or 7. That's
Yeah,
why he was a
kind
prodigy
of.
at the age of 7. He just calculated like like
Uh,
4 or 5 seconds. He could think that if you
okay.
just write this in reverse order, the sum does not change, and he paired 120. Actually, he calculated like this, this 1 to 20, right? And from 1 to 20, how many numbers are there? Like if
20.
you write 1 and 2 and 3 and 18,
Oh,
19, how many
20.
numbers? 20, right?
20.
Now,
Yeah.
if you pair like this, Yunus, the first number and the last number, what is the sum?
21.
21. And the second and the last second, what is it?
Oh, 21.
21. 3 and 18,
It
21.
should be
How many pairs we
21
have
over and
here?
over.
10, right? 10 times 21 is equal to
Yeah.
210.
Yeah.
And on purpose, they give us here, the triangle numbers. It's a special, actually, number pattern. So it's 210. Actually, in general, if you're adding n natural numbers, the sum is equal to n times n plus 1 over 2. Because you're just the first number and the last one, n plus 1, n plus 1, n plus 1. How many pairs? N over 2 pairs. Because you're dividing by 2, right? If you have 20 numbers, if you pair, we have 10
Mhm.
pairs. And 40 numbers, if you pair, there will be 20 pairs, right? Anyway, if
Mhm.
you solve this question for this, you will see that this n will be equal to, what is it? 20. In 20th figure, there will be 210 beads or dots.
Mm, okay.
Okay?
Mhm.
Anyway, there's a different method, but this is a beautiful question. It's about number pattern. Okay, Venus, let's see. I think it's the last question. Let's finish this page and we'll see. Solve the following equations, Venus. For each question, I will give you 175 seconds, okay? Do question A first.
Can I do B first?
Do what?
Can I do B first?
B first?
Yeah. I don't like the looks of A.
Why B first?
I don't really like the A, you
Why?
know? I don't know, it looks weird.
Well, what is 0.01, Yunus?
1/100.
Which is equal to 10 to the power of negative 2, right?
Okay, never mind.
Yeah. 1
Okay.
over 100
Right.
equals,
Yeah. This is
yes.
-4/3.
So the exponents are the same. 3x plus 2 equals negative 2. So x equals negative 4 over 3. Yeah. Now do
Yeah.
question B.
Okay, question B should be 11 over 2.
So it is 16 minus
Yeah,
5, right? X equals 11 over 2. And the
2.
last one?
Uh, I'm overthinking it. What? I can't make it the same base.
Another same base, Yunus. Look, this x to the power negative 2. Can you write as 1 over x squared?
Oh, okay.
And this one,
Yeah.
can I write it as 1 over x squared, the same thing?
Which one?
This 1 over x squared, is it equal to 1 over x squared?
Yeah, yeah.
And on the right hand side, 9. Is it 3 squared?
Mm-hmm.
So if 1 over x squared, if
Uh,
x squared is equal to, let's say, a squared, Yunus, what is
mm-hmm.
x?
A?
Plus or minus a,
Oh, yeah, okay.
right? Because even
Yeah.
negative number, positive number, if it's squared, it still gives us a squared. So from here then, 1 over x is equal to plus or minus 3.
Mm-hmm.
If 1 over x equals plus or minus 3, what is x?
Well, it could be negative or positive at 3. Wait. 1 over 3.
1 over 3. Yeah, just flip each side, right?
Mm-hmm.
Okay, Yunus?
Yeah.
Nice. All right. Now let's practice some from different questions. Last time we did this, and also we started with the matrices, right?
1 second.
Okay. Now we did some questions to this. Let's do some different question. All right. Let's read question 7. Yunus, can you read question 7? 8.
1 second. My headphones are out of battery, and I
Mm-hmm.
don't know if I have a connection I can use. Because I either I unplug my headphone, my microphone, or wait, 1 second. I'm gonna plug this into the back. Okay. All right, it should be good now.
Okay. Read the question.
Okay.
Question A.
Okay. The line joining the points 3, 4, and 8, 14 cuts the axis at A and B. Find the area of the triangle AOB where O is the origin. What does cuts the axis mean? Cuts
Intersect.
the
So that means
yeah.
the line that passes through the points 3, 4, and 8, 14 intersects the x and y axis at A and B.
Hmm.
Okay, we have so if the line intersects x and y axis, I don't know what kind of line. Suppose it is something like this. Sorry. Suppose it is something like this. Like this. So this one is, let's say this A, and this one is B, right? Maybe it passes through this point. We have this 2 points. And I was asking that if it is so, what is the area of this triangle? But I don't know what kind of triangle is it. I'm just giving example. First, you have to find the equation of the line that passes through these 2 points and find the x and y intercepts. And after that, find the area of the triangle. Yunus.
Hmm. So do I know which one 303 4 and which one 814 is or no?
No, no, no. You have to first write the equation. And after you get the equation, you can find the x and y intercepts, right?
As
Because
in the
these
equation
points
of
are
the line?
different points. Maybe it's 3, 4, 8, 18. If you
Oh,
draw this,
I see what you mean. Okay.
huh?
I see, I see. So I have to find the actual linear line
Yeah. First, we have to
and
find the
then
equation. Then, if
okay.
we know the equation, we can find the x and y intercepts, right?
Yeah.
Yeah. Yeah. Find the x and y intercepts and find the area of the triangle.
Okay. All right.
Did you get the equation, Yunus?
Yeah, it should be 1 second. It should be y equals 2x minus 2.
Good.
Yeah.
The first step, you need to write the equation. Y is equal to 2x minus 2, right? And now
Yeah.
let's find the x-intercept. How do you find the x-intercept?
You have to find
Y should be equal to 0, right?
yeah, when the y is 0,
If
yeah.
y equals 0, what is x?
1,
1. If x equals 0, what is y?
2, no, negative 2.
Negative 2. So that means that then we are talking about this line right here and here. So this one is y-axis. So this one is x-axis. So
Hmm.
this point is 1 and this point is negative 2, right?
Yeah.
So our line is, since it's passing through this 2 points, I don't know what are those 2 points. We are talking about this line. So it's asking the area of this triangle.
Hmm.
So now that's third step. Now what is the area of the triangle?
Yeah. Okay.
1 over 2
Base times
times
height. Yeah. Yeah.
base times height, right?
Wait. Am I looking at the? Oh, it's a right. Oh, okay.
Yeah, right angle
Which
because
is negative
x-axis, right?
2. Wait, wouldn't it be negative 2?
Yeah, this
Oh,
one,
but
let's
the
say
length
this
is still
A,
2.
this one is B. So that's equal to just 1.
Wait, if it's going down, it's negative. Is it still like 2 because it's the length of 2?
Yeah, of course. It's a coordinate
Hmm.
system, but this region, if you form the triangle, the length is 1 and height is 2 units, right?
Yeah. Yeah. Okay. Hmm. This
Okay,
is
because when
showing.
you consider the
Yeah.
length. All right, next question. What question B?
Okay. Find the
Oh,
equation of
units.
the line.
Well, A, B, C, A, B, C. Okay. Two questions and we can finish the class. Yeah, B.
Okay. Find the equation of a line passing through the point 1, 2 with slope -3. Find the coordinates of the point where this line intersects the x-axis. Okay. Well, the equation is um, y equals -3x plus 5.
Y minus 2 first is equal to
Negative
-3
3
times.
parentheses x minus 1.
Okay, then what is the equation?
Y minus 2 equals -3x plus 3. And then bring the 2 to the other side, so -3x plus 5.
Okay. Another second one, what is that? Find the coordinates of the point where this line intersects the x-axis. Okay, that means that we have to find x-intercept.
Yeah.
So to find x-intercept, y should be equal to 0, right?
Yeah, it should
If y
be
equals 0, what is x?
3 over 5.
5 over 3.
Wait, what? Oh, yeah.
Because we just solved it for x, it is 5 over 3. So then this line crosses or intersects or cuts. In different books, they use differently, but
Yeah.
intersects 5 over 3 and the 0.
Mhm.
Okay, crosses, cuts, intersects, they have the same
Yeah.
meaning. Okay, next question. C.
Okay. The simple interest on $1,462.50 for 4 years is 263.25%. Find the rate of interest per annum.
Okay.
Like
Per annum
per
means per
year.
year, annual rate.
Yeah. So it wants me to find the interest rate that it got every year, basically.
What is the simple interest formula? You remember?
Nah, I don't think I ever learned it.
You learned this in seventh grade, sixth grade.
Oh, okay, that's probably why I don't know that.
Yeah, because simple means that all actual other interest is based on this idea. So the simple interest is equal to principal multiplied by rate times time, right? Simple interest means that every year they are calculating the interest based on your initial investments. That investment does not change.
So, like, would I have to divide 263.25 by 4 to find 1 year?
That by saying that the simple interest on this, right, for 4 years is this.
Because I'm gonna have to find it per year anyway.
Yeah, this one is 263. That's our simple interest. On
Oh,
what the
okay.
principal for
Okay.
1462.50 multiplied by rate, I don't know. And the time it is 4 years.
Okay.
And now from here we have to find R. Then what is R? R will be equal to 263.25 divided by 4 times 1462.50. What is it?
Check. 0.045.
0.045. Actually,
So
it
it
is
should
in
be
decimal form, right?
should
But
be
when you're writing the
4.5%.
Yeah, when you're writing the person, always write in percent. So multiply by 100. So that is
Yeah.
4.5%. Okay, Yunus?
Yeah.
I think this much enough for today. You're also tired. We'll continue practicing. Next time, every this revision questions, every review exercise is based on like 3, 4 topics mixed. So that we have learned, so we have to solve like mixed questions. And this way, I hope you will improve your problem solving skill a lot. Yunus, have a good night. I'll see you on Sunday, right? Okay. Thank you. See you on Sunday.
So yeah.
Yeah. So.